Okay, so starting out, again, this should be a review for you guys, so hopefully you remember this, but there are 4 possible outcomes that you guys can get when you are dealing with your powers of I. Okay, so the first one is anytime you have an I to the first power, that just equals I. Okay, nothing tricky with that one there. Now, for I squared, what is I squared going to equal? The first thing we need to remember is what is the building block for all imaginary numbers? Remember, the building block for all imaginary numbers is the square root of -1 equals I. Okay, so if I have an I squared, okay, that means that technically I have a square root of -1 squared. Okay, so the squared and the square root, what's going to happen with those? Well, they're going to cancel each other. So that means that I squared actually equals -1. Okay, so I squared actually equals -1. And that's going to be important for helping us figure out the rest of these here. Okay, so I squared equals -1. That's important. We need to remember that. Next one we look at is I cubed. Well, I cubed technically would be the same thing as I squared times I, because that's technically an I to the first power, right? So add the exponents together, that gives me I cubed. Well, we just discovered that I squared actually equals -1. So really, I squared times I to the first is really a -1 times an I. What's -1 times I? Well, that is -I. So now we just found that I cubed is -I. Our last one that we're going to look at is I to the 4th. Okay, and I to the 4th, well, that's the same thing as an I squared times an I squared. So that's really a -1 times a -1. What's -1 times -1? Well, that would be a +1. Okay, so just to kind of summarize that again there, we now know that I equals I squared equals -1, I cubed equals I to the 4th equals +1. Well, what about I to the 5th? Well, I to the 5th would be the same thing as I to the 4th times I, right? And we just found out that I to the 4th is 1. So I to the 5th is really 1 times I. What's 1 times I? Well, that's just an I. So I to the 5th is I. What about I to the 6th? Well, that'd be an I to the 4th times an I squared. We know that I to the 4th is 1. We know that I squared is -1. Okay? That means that I to the 6th is -1. Okay? So you guys should be able to see as we're going, this pattern continues. I to -1 to -I to 1 to I to -1. Okay? And that pattern will keep continuing. I to the 7th, that gives me a -I. I to the 8th gives me gives me a 1. Okay? And that pattern is going to continue. Now, we can use that pattern to help us when we are trying to simplify these complex numbers when we start to multiply. Because when we start to multiply them, like if I take an I times an I, that becomes an I squared. And we have to know how to simplify that back down to our standard form of A plus BI. Okay? So, basically, every possible imaginary number that you guys have, no matter how many times you multiply it by different i's, it's got to simplify down to one of these 4 options. Okay, it has to. So, starting out with, I got 3i to the 7th plus 6i cubed minus 5i squared minus 4i to the 5th plus 6i to the 6th. So we're going to start out, I to the 7th. Well, that's really an I to the 4th and an I cubed, right? So I to the 4th, that's 1. I cubed is -I. So really 3 times 1 times -I, I've really got a -3i. So 3i to the 7th is really just a -3i. Then I've got a plus 6i cubed. Okay? Well, 6i cubed, I cubed is really a -I. So I've really got a minus 6i. Okay? Next one, I've got a -5 I squared. Well, we know that I squared is -1. I squared is -1, so -5 and -1, that gives me a +5. negative 4i to the fifth. So negative 4. I to the fifth is really an I to the fourth and an I, right? So I to the fourth is just 1. So I've got negative 4 times 1 times just an I. So that gives me a negative 4i. And then my last one is a plus 6 I to the sixth. So that's a 6 I to the fourth I squared. So 6 times 1 times negative 1. Okay, that gives me a negative 6. So my first step when I'm dealing with these, I've got all these i's up there with exponents. I have to rewrite all of those. Your I, for a final answer, your I cannot have an exponent. For your final answer, your I cannot have an exponent. Okay, because remember our final answer for all these has to be written in the form of a plus bi. Okay, so I can't have an exponent on that I for my final answer. So now that I simplified everything, I'm just going to combine all my like terms. Negative 3i, negative 6i, negative 4i. Okay, so that's going to give me negative 13i. And then I've got a 5 and a negative 6. So that gives me a negative 1. Is that my final answer? No. Has to be written in that form. So my final answer has to be negative 1 minus 13i. Okay. Next one I have is I to the 101. Okay. These ones, there's a special way to solve them. That's a super big power of I. Okay. So for this one, we have to go back. Remember that chart that we were making on the last slide where I said that the 4 just repeat themselves? Well, basically what we have to do is we have to figure out how many I to the fourth there are in 101. And why would I want to use I to the fourth? Well, because I to the fourth equals negative 1, and negative 1 is by far, or sorry. I to the fourth equals 1. I to the fourth equals 1. And 1 is by far the easiest I to simplify with. Okay, because anything times 1 is just itself. So my goal is, I've got this I to the 101. I need to figure out how many I to the fourth there are in there. So anytime you're dealing with a big power like this, you're going to take 101 divided by 4. And when I plug 101 divided by 4 into my calculator, it gives me 25.25. Okay? That 0.25 means 1/4, which means that there is 1 I left over. Right? So I've got up here 25. I've got 25 I to the fourth up there. Okay? And I got that from that number right there. There are 25 I to the fourth. And then there is one single I left at the very end. And I got that one single I from my remainder of 0.25. Okay? So these 25 I to the fourth, that's really 25 ones being multiplied together. Okay? With a single I left over. What's 1 times 1 times 1, 25 times? That's just 1. So my answer, I to the 101, is really just an I. I to the 101 is really just an I. Okay? I could do the same thing. Say that I'm trying to figure out what I to the 38th is. Okay, well, what's 38 divided by 4? Gives me 9.5. Okay, so I to the 38, there are really 9 I to the fourth. And then 0.5, that's a remainder of 1/2 or a remainder of 2/4. So there are 2 I's left over. So if there are 2 I's left over, that means that I have 9 I to the fourth. There are 9 of these I to the fourth. Okay. And then I've got 2 I's left over. So that means I've got an I squared left over. Well, all those 9 to the fourth, those are all just a bunch of 1s times each other, right? 1 times 1 times 1, and so on. Okay. That's supposed to be a 1, not an I. Okay, all those 1s multiplied together, well, those don't even matter. I to the 38th is really just an I squared, which we know is negative 1. So I to the 38th is negative 1. Okay? A couple more that we need to go over. I guess I don't need to erase that. Just go to the next slide. Okay, multiplying again. I's will just distribute like normal. So 2i times a 3 minus 2i. 2i times 3 gives me 6i. 2i times negative 2i gives me a negative 2i squared. Okay, not our final answer. Remember, final answer has to be a plus bi. Okay, so this is a 6i minus 2. I squared we know is negative 1, right? So it's a 6i plus 2. Crap. It's not 2i squared. It'd be minus 4i squared. So this would be a negative 4 times negative 1, which would make this a positive 4. My bad. Again, not final answer. 4 plus 6i would be our final answer. My bad on that. 2 times 2 is 4. Okay. Then over here, complex number times a complex number. Well, we're treating these just like variables, so you know you're going to FOIL. 2 times 4 is 8. 2 times 5i is 10i. Negative I times 4 is negative 4i. Negative I times 5i is negative 5i squared. Combine our like terms. 8 plus 6i minus 5i squared, but we know that I squared is actually negative 1. So really this is an 8 plus 6i plus 5. And the 8 and 5 come together to make 13 plus 6i. And that's my final answer for our multiplying. So hopefully that's a review for you guys from last year. You do want to remember big ones are I squared equals negative 1. I cubed equals negative I to the 4th equals 1. As long as you remember that I squared equals negative 1, you'll be able to figure out what all the rest of them are, like we did on that page. Okay, last video we have is just our rationalizing denominators.